NASA insiders are pointing fingers at SpaceX for delaying America's return to the moon. Behind closed doors, some officials are using Starship's development timeline as a weapon to push their own agendas. Meanwhile, China races toward establishing a permanent lunar base, while Washington panics about falling behind. But here's what they're not telling you. Leaked documents reveal SpaceX has completed over 20 critical Starship HLS tests. So, why is NASA really pushing for competition? Could this delay actually be part of Elon Musk's strategy to dominate the moon race? Let's go back to where this controversy really started. In 2019, the Trump administration shocked the aerospace world by announcing Artemis 3 would land in 2024. Engineers inside NASA couldn't believe what they were hearing. The timeline was 3 to 4 years ahead of what their internal projections showed. Some called it political theater. Others saw it as reckless. But here's the thing. That impossible deadline did something unexpected. It forced NASA to stop planning and start choosing, and their choice would change everything. SpaceX stepped forward with Starship HLS, a proposal so ambitious it made traditional contractors nervous. Unlike the old guard who wanted billions up front for custom-built landers, Elon Musk offered something radical. He was already building Starship for Mars and Starlink deployment. Why not adapt it for the moon? The cost difference was staggering. SpaceX's fixed-price contract meant NASA only paid when milestones were hit. No cost overruns. No endless budget amendments. Was this the deal that threatened the entire old space business model? Here's where the story gets darker. NASA Administrator Duffy recently announced he's opening the lunar lander contract to more competition, citing SpaceX's delays. Both SpaceX and Blue Origin received orders to deliver accelerated landing plans by October 29th. On the surface, this sounds reasonable, but whispers in Washington tell a different story. Sources suggest the next contract could favor Lockheed Martin and traditional aerospace giants, the same companies that thrive on cost-plus contracts where delays mean more money, not less. Is this really about getting to the moon faster or protecting an industry that's been bleeding taxpayer dollars for decades? The political pressure is real. Administrator Duffy wants Artemis boots on lunar soil before the current presidential term ends in 2028. That's not just a technical goal, it's a legacy play. Meanwhile, China's Chang'e program keeps hitting its milestones with robotic precision. Beijing announced plans for their International Lunar Research Station to be operational by 2035, with a nuclear power plant providing energy for construction. Every month that America delays, China's lead grows. So who benefits most from painting SpaceX as the problem? But here's what NASA insiders won't tell you in their carefully worded press releases. While critics attack Starship HLS for delays, SpaceX has quietly completed over 20 major hardware and subsystem tests. We're not talking about PowerPoint presentations or computer simulations. These are real physical tests with actual hardware. They've run full-scale environmental control tests using a cabin module with human participants inside, measuring oxygen, nitrogen, temperature, and humidity systems in conditions that simulate the lunar environment. 4 people sat in a Starship cabin simulator for extended periods, generating real metabolic loads to prove the life support systems work. Why isn't this progress making headlines? The testing goes deeper. SpaceX built full-scale mock-ups of the HLS interior and exterior for drop testing, studying how the massive landing legs will behave when they touch actual lunar regolith. They fired the Lunar Raptor engines repeatedly, proving these monsters can throttle down to incredibly low thrust levels, essential for a gentle touchdown on the moon's surface. They've demonstrated cold starts in vacuum conditions for both surface and vacuum-optimized Raptors. Power systems for the orbital propellant depot. Tested. Docking adapters that will physically connect Starship to Orion in lunar orbit. Qualified. Even micrometeoroid debris impact radar systems are undergoing validation. Does this sound like a company that's behind schedule, or one that's methodically conquering the hardest engineering challenges in spaceflight? Let's talk about what NASA's own programs are doing. The Space Launch System, the rocket that's supposed to carry astronauts to lunar orbit, has been delayed for over a decade. Its development costs have ballooned past $23 billion. The Orion capsule's heat shield suffered damage during Artemis 1, forcing complete redesigns and months of retesting. These are NASA's own programs, managed through traditional contractors with cost-plus guarantees. Yet somehow SpaceX becomes the scapegoat. What's really driving this narrative? Right now, SpaceX is pushing toward Flight 12, the first mission featuring their upgraded Block 3 hardware. After Booster 18's unexpected explosion, attention shifted to Booster 19. Despite the setback, SpaceX still targets Q1 2026 for launch, and that timeline looks solid. On November 25th, the first sections of B-19 arrived at Starbase's Mega Bay. Within 5 days, 4 major segments were already stacked. The liquid oxygen tank section needs about 7 segments, the methane area another 3 or 4. At this pace, B-19 could be fully stacked by mid-December. Ship 39, the upper stage, waits in Mega Bay 2 for cryogenic trials before engine installation and static fire testing. These aren't promises, they're engineering milestones happening in real time. Now let's compare this to China's approach. Beijing isn't rushing. They're building systematically through 3 phases: reconnaissance, construction, and habitation. Phase 1 uses the Chang'e missions to map terrain and analyze soil. They're currently midway through this phase, gathering data that will inform every decision going forward. Phase 2 brings construction, and here's where it gets interesting. The Chang'e 8 mission in 2028 will demonstrate in-situ resource utilization. Its rover will gather lunar soil, press it into molds, and bake it into bricks under intense heat. These aren't decorative blocks. They'll become roads, landing pads, and radiation shielding walls. China's turning the moon itself into their construction supply. Can America's approach compete with this level of integrated planning? Phase 3 is where China's vision crystallizes. Initially, their International Lunar Research Station will operate completely robotically, controlled from Earth. Only after every system is validated will Chinese astronauts begin long-duration stays. In 2025, China and Russia announced collaboration on a lunar nuclear power plant, leveraging Rosatom's compact reactor expertise. That reactor could provide steady energy for 3D printing structures, powering habitats, and running scientific equipment. While NASA debates contractor selection, China's already solving the power problem. Who's really ahead in this race? The irony cuts deep. Starship HLS was NASA's cheapest and most capable option. It's also the most complex, a complete reimagining of Earth-Moon transportation. Traditional landers are basically upgraded Apollo capsules. Starship is a reusable skyscraper that can carry 100 tons to the lunar surface. Development was always going to take time. Anyone who understood the engineering knew this from day one. So why did NASA choose it? Then act surprised when reality matched predictions?